Okay, right, let's start with our lecture today. We are moving on to record structures. And this is really, really important, as I've said yesterday. With record structures, we are adding almost like that one final piece of the puzzle to what we need to answer, to be able to answer our semester test 2 as well as our exam. All right, so this is what we need. We just need this piece of information. We must then learn to use it properly. That's the other important thing. We must learn to use it properly. And if we learn to use it properly, then we will be able to answer our second semester test. And then once we get used to that, there's still one final thing we also want to teach you, which is also important, and that is a different way to do your if statements. All right, and that's what we call select case in VB. But for those of you who have been programming the whole time, you will know them as switch statements. All right, so if statements are a very convoluted way of doing a certain set of range of numbers and so on, and your select case or switch statements will make it easier for you to achieve that. Okay, but that's not important. What's important is this, what we are showing you right now. This, if you do not do this, you fail. Okay, doesn't matter if your program works 100% using arrays only, you fail. You have to know how to use this in your arrays in order to pass. Okay, not get a distinction, to pass. The next big thing, which the reason why we want to introduce this to you before you go into the Easter holidays is so that you can think about it, because then hopefully as you leave this classroom, you're going to start seeing things the way record structures are supposed to be. Okay, so let's go. So the checklist for today is, how do we create our own custom data structures? And in other words, how do you define your own? All right. So think of it this way. With functions, you know, when you were first introduced to functions, what was the first time you were introduced to functions? What was the first function you used? Do you remember? C-string, C-int, C-dbl. Remember, it was one of those, right? You used one of them somewhere. Okay. Did you have to make your own? Did you have to write your own? No, it was built in, right? And however, as we then moved along, we realized there were certain things that we needed to want the computer to do repeatedly, but we couldn't get them to do it because it was too special. It was too customized for our needs. For example, the place text or the PIG, which is place in grid, remember? Those subroutines were very specific to what we want to do. So we had to write our own code. And so we made our own subroutine. We made our own functions. Does this make sense? Right. This is the same with a record structure. A record structure is effectively you saying, well, VB has built-in data types. You've got integer, string, double, boolean, etc. But it's not sufficient for what I need to do. And that is, I need to work with different types of data, which is a lot more complicated. It's a lot more complex. It actually is a grouping of different types of data that combine describe one entity. Are you still following me? Online people, are you still following? All right, physical people, you're still following. Okay, so the idea now is then you need to learn how to define your own, because you know how to define your own function, you know how to define your own subroutine, but now you need to learn how to define your own data structure so then you can then use it. You know how to use a function that you create, you know how to use a subroutine you create, but now you need to learn the same thing for data structures as well, data types, all right? And then the next, the last one, the really, really important thing is, okay, you know how to do it. How do you do it properly in a second semester test or exam? And I'm not even going to say or exam. I'm going to say semester test too, because I want you to be optimistic. I want you to go, hey, you know what? I'm going to get 70% semester mark because it's achievable. Who thinks it's achievable? With you right now, as is. You're like, I reckon, okay, I suppose you're like, no, not really. I don't know anything about record structure. Yeah, but I mean, knowing what you know so far, okay? You know how to define functions and subroutines, right? So if I say, okay, we're going to do the same thing, but for data type, shouldn't be that difficult, right? You hope? Okay. All right, so let's see what happens. Consider you, because I've been using you guys as an example, because that's what you're used to, right? I mean, you know yourselves. Okay, so something simple, you. Let's assume that the University of Johannesburg would like to keep track of all its students. Each student has the following information: student number, surname, initials, grade 12 marks, all of them. Let's assume there's 6 of them. And then the grade 12 average. Let's say this is all the information we want about you as a student for record keeping on the UJ information system. And they do want us to display the grade 12 marks and calculate, store, and display the averages. All right? So we need variables, obviously. Now, we could do it this way. Yes? Right? Does this make sense? Arrays? Yes? Mm-hmm. Who likes this idea? Nobody. Why not? Because we all hate having to declare variables. Lots and lots and lots of them. That's why we that's why we started to love arrays, right? We started to love arrays because we go, arrays are great because we don't have to declare single variables. But it turns out that as problems get more complex, arrays take us back to where we started. It's, yeah, slightly better than single variables, but it's so horrible. Okay, and so we don't want something like this. And then there's another thing we should consider. Student nums, surnames, initials, grade 12, subject 1 marks, grade 12, subject 2 marks, grade 12, subject 3 marks, grade 12, subject 4 marks, subject 5 marks, subject 6 marks, grade 12 averages. What is the size of all those arrays? Are they the same size or are they different sizes? Would you agree that they are all the same size? It depends on what? It depends on one single integer value, and that is how many grade 12 students are we talking about? Does this make sense? You agree that that's how it works, how it works? Because I'm not going to go, listen, there will be, I have 100 students, but there will only be 60 student numbers and 20 surnames. Does that make sense? No. If there are 100 students, then there should be 100 student numbers, 100 surnames, 100 initials, 100 blah, 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 blah. Right. So there is a relationship between all these arrays. Because would you agree that each and every single student needs to have every single piece of information here? So think about all of you sitting here, all of you online. Would you agree that you would each have a student number? You would each have a surname. You would each have initials. Grade 12, 1, 2, 3, 4, 5, 6, and an average. Okay, so what we're trying to get at is we would like to take this and group it into a single data type. All right? So in other words, instead of working with all these different arrays, we would like to define a record structure that says when you want to describe a student, the student will have the following properties. Does this sound familiar? Think about when you drop drag and drop a control onto a form, like a text box, or a label, or a button. And on the right, there's a properties window, and it shows you all the different properties linked to that control. This is effectively the same idea. You are saying, let me create my own data type, which contains a number of properties. Okay. The student data type is so you can create a variable that is of type student, and then when you enter information about that student, it would be, there's a property for their name, their surname, and so on. All right. Okay, so Malale is saying it is like a class. Yes, so for those of you who have been programming, yes, it is like a class, except it is not a class. There's a big difference between a record structure and a class, and that big difference is that a class will contain functions as well, whereas a record structure is merely a data type. Okay, there's no function, there's no code attached to the record structure itself. You're merely defining a data structure. Okay, so as you can see here, if that was the case, that we go, if we are working this array situation, you'll see that once we figure out how many there are, there would be all those read exercise statements. And let's be honest now, how many of you are a big fan of having to type code out so repetitively? Because this is rather repetitive, isn't it? Okay, so this is not ideal. But the reason why we're showing you this code is so that, number one, we show you, imagine you had to do this with arrays, without record structures. Life would suck. Okay, that's what I'm saying. Life would suck. It would. So we don't want life to suck because you are using a computer. A computer does all the things for you, right? Okay, that's why you're here, right? You're not here because you want to do more work than a computer. Anyone here want to signing up for this module because they think, oh, I must work harder than a computer? Nobody. Nobody wants to volunteer that. Sure. Okay, fine. So then what happens is we say, fine, we don't want to do it this way, but we want to show you what would happen if you had to do it this way. And that's this. Right. Now, you will see here that we could also do the following. Okay. So this is slightly better. All right. Slightly. So what have I done that's different? Well, everything is pretty much the same, except, let me get my laser pointer thingy. And you see that this line 5, I've compacted the grade 12 marks into a two-dimensional array. All right. So in other words, we will have two-dimensional arrays. The one dimension will be 1, 2, 3, 4, 5, 6. And then the other dimension is for all the marks attached to that. Okay, does this make sense? Right, so we could do this. We could, all right. And then we would do this instead. All right, so you see that on line 5, we resize it to n students, and then we know that the second dimension is 6 because there's 6 marks. Well, there's 6 subjects. Does this make sense? Okay, so in a way, it's like, okay, this is slightly better. It's less work. Okay. But can we not do better? Yes, we can. So I'm not even going to like this. Maybe we can't, maybe we can. You all know the answer is yes. That's why we're here and having this lecture in the first place. So we're going to do a record structure. Now, a record structure, as I said, is effectively a custom data type. You are going, just as you did with, the functions, the built-in functions are not good enough for me. I'm going to build my own functions. I'm going to build my own subroutines. Yeah, this is how it works. And it's just as I demonstrate here. You start off by declaring private, okay, structure. There's a new keyword for you, structure. So private, structure, and then the name of the record structure you want. So in other words, you know how when you declare a normal variable, you go private, my number as integer. Integer is the data type, right? Over here, that name there, student rec, is your data type. So if you want to declare a variable of this type of data, you would go private my student as student rec. Okay, so student rec would now be a type of data that you can use, like it was integer or double or string or boolean. And then inside there, and this is really, really important, this is like, if you don't pay attention to me right now, or you don't remember me saying this to you right now, you're going to fail your second semester test. And I don't know if this is the right strategy to tell you, if you don't do this, you'll fail. You don't do this, you'll fail. Because, I mean, if you've heard me, you'll see, wow, that's a lot of places to fail at. But is it really asking you so much? Is it like really complicated stuff that's going to cause you to fail? You must make sure that every property you define inside this record structure is public. Okay, cannot be private, it must be public. That's why you see it is public there. All right. So you see that lines 2 to 6. I'd like to ask you all to comment. Lines 2 to 6. Is there anything very difficult or very different from how you declare normal variables? Other than it's public in the front? No. So what I'm trying to get at is, when you define your record structure, all you're really doing differently now is that you're taking a bunch of normal variable declarations, instead of using private, using public, and making sure that it's contained between two lines, the one being private structure and then the name of the structure, and then ending it off with end structure. That is it. Okay, having said that to you, before I explain the difference between public and private, which actually Jay Haram sir has explained already, but I'll explain for the class in front of me, is who of you reckon you can, after this lecture now, define your own record structure? Hands up high. If you reckon, yeah, I can define my own record structure. I'm not saying use it, just define it. Who reckons they can define one? Okay, all right. Okay, it's not for a lot of marks, but you must get it right. So, over here, why do we use public instead of private? Now, you all know what private and public means, right? In English, normal English. So if you have a private party, so you want to have a party this Easter weekend. Woo, party, okay? And it's private. Who can come to your party? If it's a private party, who can come to your party? Only the people that you allow, you invited, right? If it's a public party, everyone. Okay, so here's the whole thing of private and public. We normally use private to say nobody else can act, nobody outside of where it is defined can have access to these variables. Now, when you normally declare a variable, you declare everything as private, right? But it's all private inside between two lines, class and end class. And everything inside that class is your private information. And it's okay, because this program doesn't need to share anything about its, about the values of the variable. So you keep it private. That makes sense. It's good security. With this definition here, because you define a structure, if you have left this private in here, it means that only these variables inside will know what's going on. But you're planning to use this data structure elsewhere in the program, okay? Basically outside this border and that border. And so you need to make sure these are public so that the rest of the code in your class can see what's inside this little definition you have. All right, that's why you make it public. Now, if you forgot and you made it private, you will very quickly find out that you can't access those properties when you're busy programming and referring to these properties. Right, so keep that in mind. Okay, so there was another question. Jay Barrett is asking, would grade 12 marks have a comma in the brackets? And the answer is no. We would not have a comma in the brackets here at this point because here's the thing. This record structure describes exactly one student, okay? So for one student, we want to know about their marks. Their grade 12 marks. Would it be a one-dimensional array or a two-dimensional array? It is one-dimensional. All right. Previously, we had it to be two-dimensional because it had to represent the number of students as well as the 6 subjects. But in this case here, we don't need to do that. We are saying there are going to be 6 subjects only, marks for those 6 subjects. So it's a single-dimensional array again. All right. Okay. So, declaring the data type for use. So okay, fine, we've defined it. Now we want to use it. So how do we use the variable? Well, the way to use it is as follows. So again, I declare the number of students, which is my dimension integer variable, okay, to indicate I'm interested in so many students. And then on top of it, here is the magic little line on line 12. We've got private students, and here's something I really insist on. It's not even a matter of style, it's a matter of common sense. When you declare a variable that happens to be an array, I insist that you use a plural. Because an array implies that there's more than one value. Does this make sense? Okay, so you see that I go students, open bracket, close bracket, because I don't know how many students there are, as student rec. Do you remember where we saw student rec? We saw it previously on the previous slide when we used it as the name of our record structure. So by doing this, we got as student rec, we go, so this is a variable, it happens to be an array. It's going to be capable of storing a whole bunch of student rec information. And each student rec will have a number of properties, one of which includes a dynamic array. Okay, now someone might ask, but we know there are 6 subjects. So can't we use a fixed size array in our definition, in our record structure? And I would say the answer is no. Don't do that. The reason being is at some point Visual Studio went and did a few updates and they decided that it was a silly idea to use a fixed size array in a record structure. Even if you know exactly how many things there are in that array, they are going to insist that it's better programming for you to work it as a dynamic array instead. And it actually does make sense. You see, at this point, they do not know how many of these you need. So rather than allocate space for 6 already, sitting in memory somewhere, they can't. They need to know how many of these you need. How many students do you need? Oh, you need 20 students. Okay, if we know how many students you have, it's 20 students, then we know that we have to allocate 6 spaces for those 20 students each. But tell us later. All right, so just keep that in mind. Right, so how do you work through the code? Well, you can see here, the idea is you first get the dimensions of your array, then you have VB allocate memory for that array of your record structure, and then you set the grid to the correct size. Now, over here, you see line 15, very simple. There's only one dimension we're working with, and that is how many students do we need? So that's what we've got. We've got how many students do we need, and then the very next line is easy peasy, right? It's straightforward. It's how we normally work, and that is redim the array to n students. Simple, yes? Does that make sense? You're saying, look, I need so many student record structures. Redim the array so that you give me this many student record structures. However, you're sitting there going, wait, hang on. Line 18 to 20, what's going on there? And then there's a comment here. This is super important. Exclamation mark, exclamation mark. Remember to do it, exclamation mark. Just a suggestion. No. You always say things are important. I'm not going to listen to you now. Who wants to guess what will happen if you decide it's only a suggestion? I think you can all guess. I've been saying it a lot today. Are you all ready to tell me what you think is going to happen? You're going to fail. Right, you're going to fail so bad. And you're going to sit there, why? Because it's not obvious. What happens here, ladies and gentlemen, I've got 5 minutes to try and get you, just at least get this idea into your minds, okay? Is this. Do you remember that your record structure has an array inside? Do you remember that? It was that array for the grade 12 marks. Do you remember? Here's the thing. When you tell VB, please read students to end students, all that it has done is said, okay, I will set up an array with so many student data types for you. Okay, so I've got placeholders for so many students. So let's say you have, 70 students in the class, right? We will create 70 space in memory for 70 student record structures. But what it doesn't do is it doesn't go through each and every single student record structure and say, oh, there is a two-dimensional array in there, and we need to resize that. I mean, not a two-dimensional array. There's a one-dimensional array in there for grade 12 marks, and we need to resize that grade 12 marks array inside each and every single student record structure. Does this make sense? Okay, that is why after the minute you resize your overall array, I call it the overall array because it's the array that contains everything. All right. After that, you need to then go into each and every single student and say, you, are you paying attention? Your grade 12 array, set it to 6. You, set your grade 12 array to 6. You, set it to 6. You, set it to 6. You, set it to 6. And you do it for everything. Okay. Which is the reason why I've got a for loop that goes through every single student. And inside that for loop, you see, I go readem, because you know readem is used for allocate memory, right? And it says readem the students S, because it's student 1, student 2, student 3, student 4, dot grade 12 marks to 6. Right. Does this make sense? Okay, so yes, you're resizing the marks array to size 6 for every instance of the student's data structure. Right. If you forget to do this, you will fail. Yes.
Full stop mean?
Sorry?
I'm a bit confused. What exactly does that full stop mean between students and grade 12 marks?
So line 19.
Yeah, line 19.
Okay, so line 19 here, the student's S part, okay, is basically to navigate to each and every single student in the array. But the second part is going, this is the size of that array that you want to resize it to. Okay, does this make sense? Does it make sense to you? Okay, right, yes, go ahead.
Is this similar to tuples?
Sorry?
Tuples.
No, this is not. Right, so the thing is here, student S dot, and then why is it not in square brackets? Because we don't use square brackets in VB. I wonder if you realize this. We don't use square brackets in VB. Okay, anyway, then afterwards you see that we're setting our rows and columns and we label our grid. So I'm going to stop here, all right, because we are running out of time. We have 1 minute. So please keep an eye on Eve as well as Discord. For those of you who got these magical emails, please send it to me so that I can see. And then I think the next lecturer is the Biochem HOD. I'm going to ask her if she knows what's going on. All right, thank you. Just again, ladies and gentlemen, post the lecture notes. I think I uploaded the lecture notes on Eve already, but if I haven't, I will do it after I get back to class. Thank you, online students. I will see you. If I don't see you again, then please enjoy your Easter break.